Six, two more topics, maybe more, but no, two is definite. So enjoy it. Just keep enjoying the information. All right, so what's the window size? Who's gonna tell me what the window size is? Do you know? Yeah? The what?
The maximum number of frames.
Yes. The maximum number of frames what? Okay. Anybody else wants to add to this?
Yeah, the number of frames that are allowed to be sent before acknowledgement.
The maximum number of unacknowledged frames, the frames that can be sent before having to stop and wait for an acknowledgement. That's how many frames a sender can send. Okay, I'll make a brief petition of flow control of the sliding window protocol, and then I'll continue. And then I'll ask questions after this. So we'll just get rid of the excuse that, oh, I wasn't here last Friday. So I'll repeat what we said on last Friday, and then I'll ask the questions again. All right. This should be on. Maybe. All right. So we're talking about flow control, or we talked. We talked about flow control. And flow control is what controls the flow of data between two neighboring machines, or two, even if they're not neighboring, end-to-end machines. There's always a flow control, and a flow control solves mainly one problem: the problem of a slow receiver and a fast sender. So if we have two neighboring machines, one is sending information, the sender sends a lot of information that can cause a problem to the receiver. And we call that problem flow control. So the flow control problem only happens in one condition: fast sender and a slow receiver. If it's the other way around, there's no problem. If the sender is slow and the receiver can read quickly, no problem. So the problem, if we have a faster sender and a slower receiver, then we need to slow down the sender. So that's what flow control is supposed to do. And there are, but there's one famous protocol. It's called the sliding window protocol. Sliding window protocol. And there are actually two versions of this sliding window protocol. Right. So in order for sliding window protocol, they first tried one thing in the past. It's called stop, send and stop. So you send one packet and you stop, or one frame and you stop. The receiver processes it, responds, say, okay, send me the next one. So you send the second one. So that way we make sure the sender never sends too much data to the receiver. But that it was very slow operation. So we won't even talk about it. So we'll talk about, somebody came up with this good idea that it will slow the sender if the sender is fast, but it will not even interfere if the sender is not too fast. So it doesn't really slow the system with very minimal cost. The first of those protocols is called the go back N. So this is the protocol. It's called go back N. Now, why is it called go back N? Because normally the sender will send a number of frames and ready to send the next frames and ready to send the next, but sometimes this protocol say, no, don't send the next, go back to the one you sent me earlier and start sending. They call it go back N, and N is a number. So before we talk about sliding window protocol, we need to have two other pieces of information clear. One is we need to identify, we need to have numbers to those frames. We need to give them numbers, because if we start communicating and sending a lot of information and there's something wrong with one of the frames, how does the receiver tell the sender, hey, there's a problem with this frame? So we started giving them numbers. So every frame that we send, or every packet, or every datagram, we put a number in it. We call it the sequence number. Right. So what numbers shall we use? Okay. There's only one numbering system in our minds. That starts at 0, 1, 2, 3, 4, 5, 6, 7, 8. But guess what? We can send almost 1 million frames every second. So we're going to get to a number million. And then in an hour, we'll probably get 2 trillion. And in a day, where do we stop? The number gets so big. Of course, we only write in binary. Computers only understand in binary. So imagine a binary number. Like if you want to write number 15, you need 4 bits. If you want to write 256, up to a number 256, you need 8 bits, a byte. And every time, this number is going to get bigger, bigger, and bigger, and bigger, and you won't be able to fit it in a packet. It would be too big, the number. So somebody came up with a brilliant idea. He said, let's use a small number, small range of number. Let's say in decimal, somebody said, let's go up to 999. That's the biggest number. So we start from 0, we go up to 999. When we reach 1,000, we don't go to 1,000, we go back to 0 again, recycle the same numbers. So we are recycling the numbers. And that's exactly what we do here. So, for example, we use 3 bits. So you can write 000, 001, 010, 1, 2, 3, 4. What's the biggest number you can write in 3 bits? 111 in binary. 7. Did you say 7? Yeah. So 7 is the biggest number. So we start with number 0, 1, 2, 3, 4, 5, 6, 7. And then, because we can write those numbers in 3 bits. And then we go back to 0 again, 0, 1, 2, 3. So we're continuously updating those numbers. Or we can take a byte and we can write 256 numbers. So we can take 7 bits and we can write 128 numbers from 0 to 127. And then we never increase. That's always the size. Okay, so that's the first idea. So, well, how do you tell the computer add 1 and then what's the next number? After 6, you add 1, it becomes 7. Okay, after 7, what do you say? You say add 1 and mod divided by 8. You remember that? Do you know the function mod? It's division. Divide, but only take the remainder. Do you know that's one that only takes the remainder? What's 10 divided by... No. What's 15 divided by 4? Oh, no. Divided by 6. What's 15 divided by 6? 2. And the remainder? 3. So if we say 15 mod 6, the result is 3. It only wants the remainder. So the remainder is always a smaller number than the number you divide by. And they call that the modulo. They call it the modulo. That means if you say modulo 8, that means you take any number, mod it by 8. If you say 5 divided by 8, 5 mod 8, the result is 0, but the remainder is 5. If you say 10 mod 8, that means 10 divided by 8 is 1, but we want the remainder, 2. Okay, so the word mod is modulo. That's all it means, the remainder of a division. If we divide 8 mod 8, that means 8 divided by 8, the result is 1, but we're not interested. What's the remainder? 0. Okay. You don't have to worry about that if that's kind of making... The point is, we will be using... There are actually a number of modulo systems, and the modulo systems, for example, modulo 8, that means you're allowed to use 8 numbers. 0, 1, 2, 3, 4, 5, 6, 7, and then go back to 0. So modulo 8 in this now that we're talking about in flow control, modulo 8 means we have numbers from 0 to 7 repeated all the time, and we'll be using those numbers. And then there's also modulo 1 to 8. That means we have 128 numbers, and we'll be using them. So this is an example, say, of modulo 8. What does modulo 8 means? If somebody asks, it means we have 8 numbers. We always start at 0 until 7. These are 8 numbers. If I tell you what's we're going to be using modulo 100, that means we're only going to be using 100 numbers. We start at 0 to 99. Okay, so that's what here mean by modulo. All right, so that's one thing. So that's a problem solved. So depending on what modulo, if we agree on modulo 8, that means we have 8 numbers from 0 to 7. So I send you frames number 0, 1, 2, 3, 4, 5, 6, 7. And then when I get to the next one, I go back to number 0, 1, 2, 3. So we never have big numbers. So that's, that's one thing. What's modulo 1 to 8? 0 to 127. Correct. We have 128 numbers, but they start from 0 to 127. And say modulo 512, that means we're going to be using 512 numbers. We start at 0 to 511, and then we go back to 0. So that's what modulo means. The other thing, so now we know what a modulo is. A range of numbers, that's always based on modulo n. If we say modulo 5, that means we have 5 numbers, modulo 8. So the famous ones is modulo 8 and modulo 1 to 8 and bigger ones. So we will be using modulo 8 because it's small, we can see the idea. The other thing is something called window size. The other idea is called the window size. Is the window size, it tells the maximum number of frames that the sender can send. So if I was the sender and I have 1 million frames I want to send you, I send 0, 1, 2, 3, where do I stop? So we need to agree, maybe you can absorb up to maybe 10 frames and that's it. Then you cannot, maybe for some reason. maybe your processor is so slow, or whatever, or memory, or whatever it is, you can only take 10 frames, and we agree window size is 10. That means I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I must stop. Until you send me a message and say, okay, send the rest, another 10, another 10, another 10. So that's how things go. That's called the window size. So the window size, if I ask you what's the window size, don't say it's the number of frames that the sender can send. No, it's the maximum number of frames. You can send less, okay, but don't exceed this number. That's what the window size is. Until the receiver sends you an acknowledgement. So once I say, okay, I've received those, that's called an acknowledgement. I sent you a message, say, okay, I got those 10. That means I can send you another 10. If our window size is 5, that means I can only send you 5 and stop until you send me a message. You might say, okay, I got those 5, then I send you the next 5. You might say, I only got those 2 of the 5. Well, then I can start from number 3, send you another 5 starting from that number. So the window size is, there's a better definition, is the maximum of unacknowledged frames that the sender can send. So that means I can send you because you have not acknowledged. And I have to stop at that point. That's the maximum number. If you send me acknowledgement, I can send you more. So these are the 2 important points. And now they have this system and they call it the sliding window. What does a sliding window? See, the sender will have a window of numbers. It's easy to program, so simple to program. And the window will tell you what sequence numbers you can send. Because remember, if I start at number 5, and now our window size is 5, that means I'm going to send you 5 frames. I'm going to send 5, 6, 7, and back to 0. And we're using modulo 8. If we're using modulo 8, that means you cannot send number 8. When you get that number, go back to 0. If we're using modulo 100, that means you cannot send number 100. You only reach the one before it and then go back to 0. Here's an example. If I send you frames number 0, 1, 2, 3, and then I stop, and then the next few numbers are 4, 5, 6, 7, 0. This is the normal way. But the sender and the receiver must agree what is the maximum number that the sender can send. And that's what we call the window size. So we must agree on the window size. So let's say I am the sender, you're the receiver. I'm going to send you frames. You might say, okay, let's use 3, window size 3. Now the window size will show me what frame numbers I can send. So here it is. Here's a window. Let's say here's the window size. We agree on window size 3. It's like we have a strip or a tape with a hole in it that shows 3 numbers. That's window size 3. So if you and I agree window size 3, that means I can send you only 3 frames. 0, 1, 2, and then I must stop until you send me, okay, send me the next. And then I go maybe 3, 4, 5, and then I must stop. That's what the window size is. But I want to know what are the numbers I can send. So this is the way they said, okay, have this window, have it sitting on the list of numbers. This is all the numbers that we are going to be using. So I put the leading edge of the window right at the 0. And it will show me, because this is window size 3, it will only show me 3 numbers, and these are the numbers. So I can send 0, 1, 2. I must stop, because that's the end. The window doesn't show anymore. Right. What moves the window forward? Excuse me. So what moves the window forward is the acknowledgement you send me. So if you receive the numbers 0, 1, and 2, perfect. You send me back and you say, okay, acknowledgement. That means I've received those. Go to number 3. So I have to move the back of the window to number 3. See this here where the 0 is? It's move, and there it is. I move the back of the window to number 3. And it shows me the numbers I can send. Because our window size 3, and now I can send those 3 numbers, 3, 4, and 5. For example, you didn't get number 5, or it was lost. You only got 3 and 4. So you send me an acknowledgement and say, hey, where is number 5? So I say, oh, I got an acknowledgement with number 5 in it. That means I moved my window to number 5. And now it says you can send 5, 6, and 7. So this is, they call this the sliding window. The window moves and tells me what numbers. Let's say we agreed not on window size 3, let's say we agreed on window size 5. That means we have a bigger window that has 5 spaces in it. So there it is, we start at this. This is window, if we are using window size 5. That means I am the sender, I can see in my window, I can see 5 numbers, and I can start sending. The first frame I send you will be number 0, 1, 2, 3, 4, 5, 4, and then I must stop. If you receive them all, perfect, you'll send me a message, say, okay, send me number 5. So I move my window to number 5, and there suddenly it tells me, see what it says? It says, okay, send 5, another frame 6, another frame 7, another frame 0, another frame 1. That's if I have data to send, frames to send. We assume there's a continuous supply of information going. So we just give them those numbers, 5, 6, 7, 0, and 1. See the way it recycles the number. When it reaches to 7, we don't use number 8. Because in order to write number 8, remember 7 in binary, yeah, these are the numbers in binary. 0, 0, 1, 0, 0, 0 is number 0. 1, 2, that's 2 in binary. You probably know that already. That's 3 in binary, see? And that's 4. See, to write 4, you need 3 bits. 5 is 101. 6 is 110. And 7 is 111. So where all these numbers, we just use 3 spaces. Even in decimal numbers, you can write, okay, you have 3 spaces. So you can write 0, 0, 0 in our numbers, 1, 2, 3, 5, 10, until you reach the maximum 999 in our decimal systems. So you can't write 1000 because you only have space for 3 numbers. Now for number 1000 in decimal systems, you need 4 spaces. Now here in number 8, you need another bit. That's 10008. But that takes 1 extra space, so we cannot write 8. Okay, that's why they use it. Now, if we use the numbers from 0 to 7, we only need 3 bits in the header, in the header of the packet or the data or the frame. So it's a very small space, and we can send numbers and reuse them. And if there's a problem with one of the numbers with the frames, you can identify it. You can say, hey, frame number 5 you sent me is no good, for example. Or frame number 3 is lost. Now we can pinpoint. We both know which frame. So now we can identify frames, and the space is quite limited. We don't have to waste too much space in the headers. So that's the idea of using the modulo. So modulo, so if you ask what the modulo is in sliding window, it's a way of using a range of numbers and recycling these numbers, reusing them again and again and again. And we probably go through them so many times during the communication. Okay, so that's what the sliding window, that's the window size and the modulo. So that's the general idea. Now, let's go back and start. Now we understand those 2 concepts. Now, if there's a sender and a receiver, if there are 2 users, 2 machines, and one wants to send information to the other, and the other one wants to receive, we use this sliding window protocol. And its main purpose is to allow the sender to send, but if it sends too much, it will slow it down, if it's very fast. Otherwise, it will leave the sender and the receiver. See, the receiver has to always say acknowledgement, has to send you a signal a frame to say, okay, I got up to number, for example, I sent you 0, 1, 2, 3, 4 frames. I have to send you back an acknowledgement and say, okay, I got those 3, send me number 4. And then I send you 4, 5, 6, 7. And then I say, okay, I got number 7, send me the next one. What's the next one after 7? 0. All right. So we'll try it. That's how it works. And you need to know, and you need to be able to draw on a time kind of scale diagram what I'm going to do now. So we have 2 machines, a sender and a receiver. Remember, this guy can be a sender as well, but let's just look at communication now going in one direction. But we have a sender and receiver, and we have a line in both sides, and we call it, this is time, the time scale. So time in seconds or whatever it is, millionths of a second, doesn't matter. We won't worry too much about it, but time. And these sender and the receiver, in order to send and receive, they must agree on 2 things. Anybody remembers what these 2 things are? Any ideas? We must agree on a window size. Let's say 4, for example. Okay, let's agree now on 4 or 3. 4 will do. And let's agree on something else and call the modulo. What modulo are we going to be using? What does the modulo mean? It means what range numbers are we going to be using? Are we going to go from 0 to 7 or 0 to 127 or 0 to 523 or 512? That's 511. So we need to agree what's the biggest number we can use and then go back to 0. We call that modulo. So for now, let's use modulo, the smallest modulo. Let's use modulo 8. What does modulo 8 mean? What numbers are we going to be using for modulo 8? 0 until 0, 1, 2, 3. Up to what number? What's the maximum number? Like I can get a packet and put number 0 on it, send it. Now the next one, number 1. Next one, number 3, 4, 5. What's the biggest number? 7. Yeah. Okay. And after 7, what's the number after 7 that I can put in a packet? 0. Did you say 8? Okay. 0. That's perfect. Yeah. So these are our numbers. And this is our window size 4. And there it is. So if we start, initially, I can send 4 frames. They are number 0, 1, 2, 3. And so we'll take it from there. Now, so this sender is going to send towards the receiver and always have the line going down a little bit. So this guy is going to send frame number 0. We always start with frame number 0. Don't start with frame number 5 or 3. Must start with 0. 1, 2, 3. That's 4 frames and you stop. You keep sending them. And if you start sending at time 8 o'clock, make sure the arrow goes down so it arrives a little bit later, not earlier. Don't send something at 8 and somebody gets it at 7 o'clock. No, if you send it at 8, they get it a little bit later. Okay, so don't have the arrow going upward, or means you don't understand this system at all. So this is time. This is the time. You start sending something, it'll arrive a little bit later. You send back, the receiver sends something back, it'll arrive a little bit later. Okay, always. Right, so now this guy sends frame 0, 1, 2, 3. So this guy got frame 0, 1, 2, 3. They will be in a queue. It actually only takes one at a time. They'll be in memory somewhere on the card in a queue. But at the data link layer, this will say, the data link layer should say, give me the first frame on the queue. So this guy only takes 1 frame, looks at 1 frame. And he looks at it and it's good. What does he do? What does data link layer do with the frame? Send it upward, go up to the user. Remember, every time you receive, every time you're talking to somebody outside your machine, there's a program that's running, there's an app. At layer 7, the application layer, there has to be a program running, a game, maybe a messenger, email, file transfer, some program that is receiving information from outside your computer. Let's say Messenger. Let's say you're talking to somebody on your mobile phone. So there's a program running called Messenger, the app at level 7 in the 7-layer model. And before that runs, it has to ask the communication system, can I have a port number anyway? So it gets a port number and sends it to the other side. Say, hey, any message sent to me, put this port number on it. So anyway, the message arrives to us. We are just the receiver, data link layer. We just send it up to the user or to the application or the next level. In fact, we'll be sending it to the network layer that checks it. Yeah, that's a good IP address. Send it up to the transport layer. They say, yeah, it's for us. Oh, it's port number this. I give it to this program, so it gives it to Messenger. We don't care. We just say, send it up to the user. We don't want to get into the details. Where does it go? Anything that we receive, it's a good frame, send it up to the user. If it's a bad frame, discard, delete. So this guy only does two things. Either a good frame, it receives one frame, it looks at it, checks it for errors. Maybe it does CRC, maybe whatever it is, parity check. We don't want to get into the details. It just checks it, it's perfect, send it upward to the user. I'll just write here U for user. And then looks at the next one. Is it the right one? Yeah. Send it to the user. In fact, when we start, we have the sequence number we're waiting for. Like the next frame to receive, the next frame number to receive. When we start, we just put it at 0. That means I'm waiting on frame number 0. I got it. Yes, it's 0. So now I increment this. After I get 0, now I'm waiting on number 1. I get 1, that's good. I'm waiting now on 2. I keep incrementing. Every time I successfully receive a good frame, I increment frames I'm expecting. So anyway, we get those 4 perfect frames and we send them up to our user. We look in the queue, there's nothing else. Of course, the sender can't send any more. Why? Why the sender cannot send me any more frames? I checked all these. Why the sender cannot send? Any idea? Why the sender stopped sending? Because the window size 4, it cannot send anymore. It must send 4 and wait for me to respond, to send back acknowledgement. Now, I will not respond until I check all the frames in the queue. There's nothing else in the queue? Okay, well, maybe now then I should respond. So I prepare a small frame, in fact, and they call it the acknowledgement frame. The acknowledgement frame, it's a frame that has no information, it's just the header. Remember, every frame has a header that has sequence number, the MAC address, things like that. Now it has, it also has another thing, what kind of frame it is. This is an acknowledgement frame. And all right, the acknowledgement means a number. I need a number. So what we do, if we receive perfectly those frames, 0, 1, 2, 3, we send acknowledgement. You know what acknowledgement number we send? Anybody was here on Friday? Do I send 3? That means I've received the frame up until frame number 3. What number will I send? 4. So the acknowledgement always, it means something. It means I'm telling you, I'm acknowledging. Acknowledgement means confirming I got this frame, but not this number. I got everything before number 4. So any number, anytime the receiver sends acknowledgement to the sender, confirming receiving of frames, it's important for you to remember the number that we send. It does not mean we have received that number. It means we did not receive this number, we received the one before it. Okay, so that's really important to remember this. So that's what the acknowledgement means. And I'm going to write it here. What does the acknowledgement mean? It's just an extra little bit. And that's something you need to remember as well. What does acknowledgement mean? Acknowledgement N, as in a number in the acknowledgement. So if I send you acknowledgement with any number in it, number 7, or number 20, or number 105, what does it mean? It means all frames before N, I mean, Like if I sent you here acknowledgement 4, that means put 4 instead of n. All frames before number 4 are okay. I've received them. That means I've received all frames before number 4. So anytime you receive acknowledgement 17, it does not mean you received frame number 17. You've received frame number 16. Up until frame 16 is everything is good. I did not receive number 17. Remember this. That's important about the acknowledgement. Right. It also means something else, the acknowledgement. Two things, and they do not clash with one another. It means everything before n I've received. And it also means I expect frame number n from you next. What does that mean? Here with number 4, see the acknowledgement 4, it means everything before 4 is okay, which is correct. I've received up until number 3. It also means I'm expecting this number from you next. So I'm waiting on number 4. Okay, so if I ask you what does the acknowledgement 100 mean? It means every number 99 is received and I'm waiting on number 100. Okay? So it's simple, but keep that in mind. Once you know that, you can go with the rest of the flow control. So what does this guy send? Can you help me here? Can somebody help me? You got acknowledgement number. What's the next few frames that the sender sends? How many frames will the sender send now? Remember, first it sent 0, 1, 2, 3. They're all checked perfect. The receiver sent back acknowledgement 4. Now this guy has to send a few frames. How many frames will it send? 4 frames. Why? Because the window size says 4. Right. Can you tell me what frames the sender will send?
4, 5, 6, 7.
Exactly. What about the next one, number 8? So it will send 4, 5, 6, and 7. Okay, so simple, but it's perfect. So this guy received 4 good. What will it do with frame number 4 if it's perfect? You send it to the user. Send it upward to the user. Okay, and then we look at the next frame, number 5, and it's good. We give it to the user. So remember, there's a queue. All the 4 of them arrived. Even when the first one arrives, this one starts looking, but then the second one arrives, third one arrives, especially if the sender is fast. But that's it. We know the sender will stop when it reaches number 7. So this guy checks 4, 5, 6, and 7. And this guy will send back acknowledgement. What acknowledgement number will this receiver send back?
0.
Why?
I don't know.
Okay. That's the next. 8?
No, it's not.
Oh, this is modulo 8.
No.
Modulo 8, we cannot use number 8. We have to replace it by 0. So yes.
7.
So the next frame, here it is. Now I'll show you on the, whatever it is. This is the modulo. And we're using modulo 4. Are we using modulo 4? Yeah. So that's it. We sent, is it 3 or 4? Oh, yeah, 4. So we sent first 0, 1, 2, 3. Correct. We got acknowledgement 4, so we move the window to number 4. It says send 4, 5, 6, and 7. We send 4, 5, 6, and 7. Now we got acknowledgement 0. We move the window and stop at 0 and say send 0, 1, 2, 3. Okay, so I don't know where we are here. Yeah. So that's acknowledgement 0. The next frame after 7 is 0. That's the one we expect to receive. So this guy sends now few frames. Okay, can you name the frame numbers that will be sent now? No, not you. Yeah. What frame numbers will the sender send to the receiver now? It will send 0. Yeah. And it will stop because the window size 4. And that's how the sliding window protocol works, the basic idea. Okay, so Right, let's just finish this while we're at it. Who wasn't here last Friday? The one at the very back there. What acknowledgement number? Everything is received. All these are perfect. And we sent them to the user. Don't forget to say they are good frames, send to the user. And send back acknowledgement. What acknowledgement number will the receiver send this time? 4. That means, what does acknowledgement 4 mean? What does it mean? It means two things. If I send you acknowledgement 4, what does it mean? It means everything before 4 is okay, but now I'm waiting on number 4. Okay, so it means these two things. That's what acknowledgement means. All right, so that's how it keeps working. Now, let's go to the next stage. And let's say, okay, you didn't tell me what frames will the sender send now. What frame numbers? If this guy is asking for 4, that means you must send number 4. What's the next frame? How many frames do you send? You send whatever the window size says. The window size here says 4. That means you must send 4 frames and stop. So what's the next frame? What are the frame numbers you send? 4, 5, 6, 7, and stop. Right. Now, let's say this guy got them, got number 4 is good. What will it do with this frame if it's a good, perfect frame? Send it to the user. We got number 5, there's an error with it. That's what we're expecting. We're waiting on frame 5, and it's the right one. We got number 5, but it has an error. We put it through CRC, and CRC said, hey, there's a bit error. We throw it away, discard. So there's an error, discard. D means discard. So every frame is going to be sent up to the user. If it's good, if it's bad, discard it. Now we're still waiting on frame number 5. Once the receiver gets an error, it will send back an acknowledgement immediately. What acknowledgement do you think it will send? What acknowledgement do you think it will send? 5. Why 5? What does acknowledgement 5 mean? It means number 4 is okay. Everything before 5 is okay. But hey, we need number 5. And now it means something else. It could mean maybe frame 5 has an error. Has error. So it could be an error frame. So if you get acknowledgement 17, it means number 6 up until 16 is everything is okay. Number 17, that's what I expect from you. And maybe like if you send it to me, I'm telling you it's no good, there's an error. We throw it away. Send it again. Okay, so acknowledgement, it means everything, acknowledging everything before that number, but that number, I'm waiting on it. If you've already sent it, send it again because I found something wrong with it. If you haven't sent it, that's what I need from you. Is that clear enough? Right. So this guy sends acknowledgement 5. We know what acknowledgement 5 means. Right. But remember, in the queue, the acknowledgement is just gone. So, but there are already frames already sent, number 4, 5, 6, and 7. So after 5 in the queue, we'll find the next one. We get number 6. Number 6 is perfect. There's nothing wrong with it. But we are waiting on number 5. We get number 6. What does that mean? It means, hey, that's not the frame we are waiting on. And they call this is not the right sequence. They call this out of sequence frame. So there is an error. It's called out of sequence. So I'll just write here the type of errors that you might face. One of them is a bit error. That's like the one in number 5, bit error. We found a frame with 1 bit error discovered by CRC or something like that. But now we got number 6. There's no error with it. all the bits are perfect, but we check the sequence number and we find it number 6. Can we send, remember, we discarded number 5. Imagine if you are listening to music, right? Or you're watching a video. You got lots of frames. You got frame number 4 and it's showing now. We got frame 5, we discarded it. Now we got frame 6. Can we send you frame number 6? You watch the next clip and then you watch back. It doesn't work. So we don't send you a frame out of sequence. We don't send to our users a frame that are out of sequence, even if they're good, if there's nothing wrong with them. But what's wrong with them is we call them out of sequence error, out of sequence. That means there's no bit error with it, but there's something else with it that's wrong, and it's called out of sequence. It's sequence number. So I'm waiting on number 5, I got number 6. What do I do with it? Discard it. Sorry, I can't accept, I can't send it to my users. Imagine if I send you a file and every page is in a packet. Now one page is gone, I send you the next page. So now your file is going to be missing if I send it to the user. So we don't pass it to our user. And then we get the next frame, number 7. And also it's a good frame, but it's not the frame number we want. We're waiting number 5. So we discard it as well. Okay, so this is how sliding window protocol works. If it finds something wrong with a frame, most likely it will discard the ones after it as well. Why? Because they are out of sequence. You cannot send them to our user. If you send them to, if our user if we send everything to our user except the discarded one, the bad one, then they'll have a file not the same as the one that the sender is sending us. Okay, so we discard those. And remember, this guy, every time this guy sends those 4 frames, it goes to sleep. When does it wake up? When the acknowledgement arrives, the operating system will wake up and say, hey, wake up, there's something for you in the post. It's like the letter arrives in your house and your friend or your mother wakes up and say, hey, excuse me, go check the post. There's something, or somebody at the door. And same with this one. This is normal way of programming in computing in general. It's a good way of programming. If you're waiting on something, don't keep checking. Is it there? Is it there? Is it there? That's bad. Don't write it in a loop. I don't know if you've started programming, if you've done loops. A loop, for example, you start checking for something. Is x equal 5 or 0? You keep checking, is it equal 0? Is it equal 0? That's bad programming because you're using the CPU for nothing. You're doing, it's like you're waiting on a friend. You go on a drive and you're waiting on, say, a friend. You want to pick them up and go somewhere. You arrive at their house at 6 o'clock, exactly. They say, come and pick me up at 6. You go there, you stop outside the house and the engine is running. They're supposed to come down now, but you're waiting and the engine is running. And you're going nowhere, you're waiting, the engine is running. And then 10 minutes later or 20 minutes later, the friend comes down. So for those 20 minutes, the engine was running, wasting fuel and going nowhere. You're waiting. They call that busy wait. In computing, we don't do that. We don't use the CPU. Remember, every time you check, is x equal 0, is x equal 0, you use the CPU. So why should you be using the CPU a million times in 1 minute or less than a minute or a few seconds? It's best to go to sleep and tell the operating system, when this happened, when this event happens, wake me up. So that's the best way to do it. It's the least energy consuming, the least CPU consuming, and this is used a lot in computing, in programming. You ask the operating system, I'm going to go to sleep. If something comes on my communication line, wake me up. And that's how so that's an event. So the sender and the receiver, they do that. So the receiver would be asleep. The receiver isn't just sitting waiting. Hey, it's like you sitting waiting at the post office. You're waiting for an important letter and you're at the kind of the sitting room. You say, everything here, I'll go and check the post. Is there something in the post? You keep checking every 10 seconds. That's bad. No. Here, the receiver goes to sleep. If something comes, it will be awakened by the operating system. Normally by the physical layer. Physical layer will wake you up when there's a frame, puts it in memory and wake you up. Hey, data link layer, there's a frame there. So you're awakened. And then you look at all the frames. When this is empty, you send an acknowledgement, you go to sleep. You wait whenever something else comes, because you don't know when the sender is going to send you information. It's not always continuous. Sometimes there's 10 minutes no communication. You don't want to be using the CPU. Anyway, so the point here, this is called event driven. So all your controls, the things that get you moving, are events. Whenever the event happens, you will be awakened and you will work, you will operate. So now the user goes to sleep, sends acknowledgement, goes to sleep. This guy gets the acknowledgement, it's wakened up. He says, oh, acknowledgement 4, then I can send number 4, 5, 6, and 7, sends them and go to sleep. This guy gets the packets 4 and 5. They tell you some information is in memory. Start checking it to find packet 4, 5, 6, 7, send acknowledgement 0, go to sleep, and so on. So let's get back. That's just the way things work, and it's good to know. So now this guy receives good frame number 4, bad frame number 5, send acknowledgement 5, checks that number 6 and 7, they are good frames, but for us they're bad, wrong, because they have the wrong sequence number. So that's another error that we delete them. We delete them, we go to sleep. So this guy gets the acknowledgement 5. Imagine this. We got to the point where this guy sent 4, 5, 6, and 7. That's the window 4 is working here. And we sent 4, 5, 6, and 7. And it's waiting for acknowledgement 0. It's always pointing to the next frame. I'm going to send the next frame, which is number 0. But instead of getting a 0 and moving to that point, no, it says go back to number 5. So acknowledgement 5 means, hey, send me back number 5. So we move the window up to number 5, and the window tells you, okay, now you can send 5, 6, 7, and 0. The sender here will have to send 5, 6, 7, and 0. Okay, get that? Okay, let's say 5, 6, and 7 are good, and 0 has a problem. So 5, 6, and 7 are sent to the user, and now we're waiting on 0, and we send back acknowledgement. What acknowledgement is sent back? The very end there. What acknowledgement will the receiver send back? That 5 is good, 6 is good, 7 is good, but there's an error with number 0. What acknowledgement will we send back? 7 or 0 or 1? The very back there. Any idea? What do you think? What acknowledgement will be sent back? 0. Remember, the acknowledgement always means the one before it is okay, and 7 is okay. So you don't send 7. If it's okay, don't send number 7. Send the one after it. The one after it is 0. Remember the acknowledgement? Remember that acknowledgement means everything before number 7 is okay, which is correct in this side, in this situation. Everything before 0 is okay, which is number 7 is okay. I expect number 0. Yes, there's something wrong. I want you to send me number 0. And maybe it's something wrong with number 0. Yes, actually, there was something wrong with number 0. So that's what the acknowledgement means. Right. What would the sender send now? The guy at the window there. Okay, the guy behind the one at the window. Yeah. What will the sender send? What frame number? Good. So, pardon? Just 0. Yeah, that's better. Why? Because the window size says 4. I always assume there's plenty of data. So now let's continue. Send on the receiver. Window size. Shall we change the window size? Let's go for window size 5. Modulo 8. The time. We start right at the beginning. what frames will the sender send? Window size is 5, modulo is 8. Fine. Why is just 4? Because the window size says 5. These are 5 frames from 0 to 4. All right. Now, if they're all received perfectly correctly, 0, 1, 2, 3, 4, and they're all, so we'll send them to the user. I'll save you this, right? And then we're going to send back acknowledgement. What acknowledgement will the sender send back? Are you sure? What does the acknowledgement 5 mean? Yeah. Anything else? What else does it mean? I'm waiting on number 5. I expect number 5 next from you. So, right, so this guy, what frames will this guy send? Yeah. 6. Say them quick. I don't have to say yes, next, go on. 5, 6, and 7, right? Two. Okay. All right. Now, imagine if we got 5, 6, 7, 0, and 1, and there's something wrong with number 7. Or, not wrong, we never got it. We never got number 7. We got 5, 6, 0, and 1. They call this kind of error. See the kind of errors and how we deal with them? We call it the lost frame. So sometimes we lose a frame completely. How do we know? How does the receiver know a frame is lost? How do you know? How did he know here the receiver frame is lost? We got 5, 6, 0, and 1. If you get an out of sequence, then you know there's a missing frame. If I send you 1, 2, 3, 4, but you get 1, 3, 4, then you say, hey, where's number 2? So that's the lost frame. So if you get a sequence of frames, one of them is not there, then that's how we discover. So if you are asked, in this system, who discovers a lost frame? It's always the receiver who discovers it. How does the receiver discover a lost frame? He's going to get frames without one of those. It's going to be an out of sequence frame. So if you get 1, 3, 4, 5, you say, hey, where's number 2? So you know there is a missing frame. So that's the next error. It's called a lost frame. If a frame is lost, what happens? How does the receiver know? The receiver will only know the frame is lost if it gets the one after it. See, if this frame is lost, the last one, number 1 is lost, the receiver will not know. We just say, okay, I got 5, 6, 7, 0. It doesn't say where is 1. Maybe that's it. Maybe there's no more data. Maybe the message, the file I was downloading, finished. You don't have to the sender does not have to keep sending frames or messages unless there's a message to send. Okay, it's the last frame. The receiver will not know it's lost. But what it will send an acknowledgement for frame number 0, which the sender will know it is kind of lost because. Anyway, so let's take this at a time. Number 7 is lost. So the receiver receives number 5, says, okay, good, send it to the user. Number 6, send to the user. Got number 0. It's a good frame. But hey, I say, hold on, I'm waiting on number 7. So this is an out of sequence frame. It says, well, then the other one is missing. I didn't get it. There's nothing wrong with, if I had got it and there's something wrong, okay, we know then there's an error in it. But we didn't get it. We got the one after it. That means out of sequence. So what does the receiver do? Anytime it discovers a frame with an error or a missing frame, it will send back acknowledgement. Now, what? Are you sure? 7? Why 7? Because everything before 7 is good, and this is the one that's probably missing, and that's what I want from you. Right, and then we got number 0 and 1, and they're good frames. What do we do with them? They're out of sequence. We cannot take them. we cannot send to our user frame number 0 because there is another frame before it that's not there. So what do we do with 0 and 1? Discard. Anything out of sequence you must discard. Now, this is now the next problem that we have. Imagine what we are sending is conversation. Like two people are talking, live talk. Like for example, somebody's talking and we are recording it and we are sending it down to the receiver. Now, every time the person talks, we take a few seconds and put them into binary, into a packet and send it. So that's 5 contains the sound. This guy talked about 5 for 5 seconds or 10 seconds. That's a packet. And then the next frame contains the next few seconds of speech. And then number 7 contains the next few seconds of speech. But how can we send it back? You can't ask the sender, the person who is talking, say, can you repeat what you said about 15 seconds ago? We don't do that. You cannot ask them to repeat it. So, how do we send this exactly the same frame? Well, there is a requirement. This is the way things work now. Every time the sender sends a frame, it must keep a copy of it in its memory. So here the sender will keep a copy in its memory in frame number 0, 1, 2, 3, and 4. In memory. And send them, give them to the physical layer, send, but don't delete, keep it. Until we receive acknowledgement. You only delete it or clear it once you get acknowledgement that it has been received. Okay, so it's like I give you a document and I say, send it by, put it in a scanner and send it to somebody. But keep it until they tell you, okay, we got it. Don't throw it in the bin yet. Yeah, that's exactly what the sender does. So now, for the first time, we realize, oh, the sender needs memory. So in this system, the sender needs memory. Enough memory. How much memory do we need? How much memory do you think the sender will need? If we can generalize it. Any idea? Enough for 100 frames? Or 1,000,000 frames? Whatever the window size, the agreed window size. So if, for example, every frame is 1,000 bytes, and I have, say, 10,000 bytes in my memory at the data link layer, how many frames, what's the maximum window size I can go for? It's 10, because I have to keep copies in my memory of every frame I send. I only have 10,000 bytes. That means I can only store 10,000 bytes of frames. And if every frame is 1,000 bytes, that means 10 is the maximum I can store. Okay, so now there is a restriction on the sender only. The sender must have memory. And do you know how much memory? It's whatever the window size is. As many frames as the window size specifies. It's as much memory that will store the number of frames. So in order to calculate it exactly, if I say exactly how much memory does the sender here is using, you say, okay, you better tell me how big is each frame is. So what's the maximum size of each frame? Let's say every frame is 2,000 bytes. Then we have 5, then 10,000. That's the window size, the memory requirement of the sender. The receiver, remember, the receiver only picks one frame, looks at it, and send it to the user or discard it. So it only needs space for one frame. Even though frames may arrive in a queue, but that's not in the data link layer memory. That's in the, whatever, the system memory or the card memory, but not in our data link layer. So memory is allocated to the data link layer. The sender can have some, the receiver can have some. The receiver only needs one space. Every time there's a frame, puts it in it, process it. Let's check it for error, check the sequence number, everything is good, send it to the user. If it's bad, discard it, get the next frame. So you don't need a lot of memory, only one space, but the sender needs. So if you and I agree, okay, let's talk about negotiate window size. Shall we use 2 or 100? Who is it more critical? The sender is more critical. Say, hold on, 100. That means I'm going to need 200,000 bytes because every frame is 1,000 bytes, and I don't have that much memory. So I can't agree on memory on window size 200. Okay, so that's the point. Is now, if you're asked to explain this, you say every time, you say, let's say, that's how you start. If you're asked to describe this, right? Just at the critical point and time. So we start the sliding window protocol, go back in. Sender and receiver must agree on a window size and a modulo. Every time the sender sends a frames, sends as many the window size specifies, must keep a copy of every frame. So you either write it in English or draw it like this. And I'll assume if I see you drawing here, these boxes with numbers on them, I know, oh, you mean you're going to keep copies of it. So instead of writing it in long English, you can just do that, and I will read the words on your behalf. Okay, so especially if you have a problem with English. Okay, the next thing, this guy sends acknowledgement, goes, this one guy's acknowledgement 5. What does it mean? Hey, that means all the frames before 5. We have copies, so we can delete them all. That's it, we can clear our memory. Because acknowledgement 5 clears memory. Now we have clear memory, and we can send the next few frames. Of course, now don't forget to say, oh, we must keep copies of those frames we sent, 5, 6, 7, 0, and 1. Now when we receive acknowledgement 7, what does it mean? Number 6 is okay. So number 6 is acknowledged. We can delete everything from memory here, 5 and 6. But don't delete 7. Now we have a copy of 7, so we send it again. So now that's why we send 7, bring it down here, but it's in the same place. 7, 0, and we send 1, 2, and 3. I should have asked you what frame numbers, but you already know at this stage. Because window size is 5, 0, 7, 0, 1, 2, 3. That's 5 frames. Okay, you see the idea here? Everybody understands how it works so far? Let's do it again. This guy got 7, 0, 1, 2, 3. Let's say something went wrong with number 1. 7, 0, 1, 2, 3. Lost or has an error? Let's say error. What happens to number 7? Like if you're explaining, you need to tell me what happens to every frame. What do you do with frame number 7? Frame number 7 is okay. What do we do with it? Discard it? It goes to the user. Number 0 is okay. User. Number 1 has an error. Discard it or send to the user? Yeah, okay, but let me first know, is it discarded? It's discarded. And also an acknowledgement is sent. What acknowledgement number will go there? You sure? Well, you just heard them saying 1. Okay, last time. What acknowledgement number? 1. Thank you. Correct. All right. And the receiver is still working. It starts sending, maybe the physical layer starts sending that acknowledgement, but looks at number 2. Number 2 is okay. What will we do with it? Is number 2 okay? It has no error. Why discard it? Yeah, so it's out of sequence. So we're looking for number 1. We got number 2. That's out of sequence. So discard. Number 3 is also discarded. Okay, so the sender receives this acknowledgement number 1. It looks at its packet here. It's going to delete some of these frames, clear them off memory. What frames are cleared from the memory here? It got acknowledgement 1. What does it mean? What does acknowledgement 1 mean? Is received. So now we can get rid of everything before 1. What's before 1 here? Is 7 before 1? Yeah, 7 and 0 are okay. They're gone. So now we have to send back number 1. All right. 1, 2, what else? 3. Are you sure? And then that's it. 1, 2, 3, and 4, right? Because our window size is 5. Yeah, I can't hear you. We have to be clear. She's just moving the lips. So 5. But okay, yeah. So because the window size 5, always send 5 frames. If the window size 3, only send 3 frames. Right. Now I'm gonna try something else now. 1, 2, 3, 4, 5. They're all received perfectly. What do we do with them? We send them to the user. And we send back acknowledgement. What acknowledgement shall we send back? What do you think? Acknowledgement number to send back. We got frame 1, 2, 3, 4, 5. All perfect. Send them to our user. We send back acknowledgement. What acknowledgement number? 6. Thank you. Now, do you know something? This acknowledgement 6 was lost. This guy here sent, and remember, he kept copies. Don't forget, this guy kept copies of 1, 2, 3, 4, and 5. You must always do those little copies. And it's gone to sleep. Every time, remember, this is an event-driven system. So this guy sends those 5 frames and go to sleep. It's going to be awakened. Who's going to wake it up? When the acknowledgement arrives. Every time the acknowledgement arrives, the system says, wake up, there's an acknowledgement, say, oh, 6, delete this and send number 6. But now the acknowledgement is lost. So this guy is not going to wake up. Maybe the receiver will wake up. The receiver, every time the receiver sends an acknowledgement, it goes to sleep. It's going to be awakened by more frames coming in. Sends acknowledgement, go to sleep until something arrives. Now, sends acknowledgement, go to sleep. This guy is asleep and that guy is asleep. The acknowledgement is sent, is lost. It's not going to get there. So both of them go to sleep. Usually, this is the way system works. I go to sleep, you wake me up. You send me data, I'll wake up, I'll deal with it. You go to sleep, I send you acknowledgement. The acknowledgement wake you up. If you have data to send it. Of course, usually the acknowledgement will wake you up, but maybe even when you're asleep before the acknowledgement, your user says, hey, send this more data. We have more data to send. But you can't send it. You say, okay, whenever I've sent the maximum number. So the sender is going to go to sleep until the acknowledgement is received. The acknowledgement is never going to get received. Why? Because it's lost. And there's nothing in the protocol that tells the receiver, hey, send another acknowledgement. Why should I? I didn't get anything. So they're both asleep. And this is the problem with the system. So what they did, they solved it by putting something else. They took an alarm. They call it the timer. So it's like you go to sleep, but you set the alarm for 6 o'clock in the morning. Of course, I'm only joking. 10 o'clock in the morning in your case. So you set the alarm for a certain time. And you go to sleep, and the alarm says, means wake up. Right? Same here. Every time the sender sends a frame, so easy. And clocks and time is perfect with computers. You can set any alarm for a tiny millionth of a second if you want. Well, anyway, so we set the alarm every time. Now, that's what you need to say. Every time the sender sends a few packets, it will keep a copy of every packet, and it will also start a timer for every packet. So there's a timer for frame number 0. There's a timer for frame number 1, a timer for number 2, timer 4, 3, and 4. You know, those timers you have in your mobile phone, you say, hey, set a timer for maybe 7 minutes if you put something in the oven, and the timer will go off. That's exactly what it is. It's saying, start a timer. But how long is the timer? It's a agreed one. Usually, the timer, it says, I'm going to send packet number 1. The timer has to be, let's calculate the time when the timer should go off. Nice for it to go off. For example, every time we send the timer, we send this packet, let's say it takes, for example, 3 millionths of a second to send. It's even less, but let's say it takes 3 millionths of a second. And it takes for this guy maybe to process it maybe another 3 millionths of a second. So that's 6 millionths of a second. And then for this guy to send us back acknowledgement takes another 3 millionths of a second, let's say 9. Okay, multiply this into 10, and that's the time I will do, say 90 milliseconds. Okay, so it's plenty of time. We don't want these timers going off all the time, alarms going off. So what we do, for example, set this timer, whatever the network will agree, or usually 40 milliseconds, 50, 60, usually below 100 milliseconds. Enough time. This is only in emergency. If something goes wrong, this alarm will go off. So you don't want it to go if they're a little bit busy and they took a little bit longer time. So only if really the delay is going to be quite bad. And in our case, we'll say 100 million seconds, like 1/10 of a second or less, you know, or less than 100. 100 is less than a 1/10 of a second. But anyway. So we set the timer for long enough. So if this guy goes sleep, this is lost, and this guy's sleep, it will be awakened by these little timers. One after the other, they'll go. It depends on when they started them up. That's the only difference. By preparing a packet frame, everything, send it, start the timer. And start work on the next one, send it and start the timer. So it will take a tiny bit. So, but timer 1 will go first, for certain. And then it'll be followed by timer 2, timer 3, timer 4, and timer 5. Normally, look at the top one here. We kept a copy of frame 0, 1, 2, 3, and we started timer 0, timer 1, 2, 3. We set 5 timers. So easy and simple in computing, inside the computer to ask for a timer. But anyway, and cheap. But let's say we sent it. We sent this message. The timers are working. And then we received the acknowledgement. And we said, first thing, delete the packet. But also, switch off, turn off the timers. So those alarms, turn them off. It's like you, for example, at home, sleep, maybe with a friend of yours, and you want to set up the timer, say, for 9 o'clock, right? But you woke up at 7:30. So you don't want the alarm to go off. You've already, so you go and switch it off, turn it off before it goes off. You woke up before the alarm, so it won't disturb anybody else. So same here. We set the timer, but if we get the acknowledgement, go and turn all the timers. There's no point, there's no need. We set them just in case if we have to send them again. We've already received an acknowledgement. So we go and turn those timers off. Okay, so in fact now, when you send a message, when you send these frames, it's an event driven. Now we have 2 events that might wake you up. So when you go to sleep after sending these frames, there are 2 possible events that can wake you up. Either an acknowledgement is received or the timer will go off. Okay? It's like you go to sleep and you set your alarm at 7, but you say to ask your friend to call you. So you're going to go to sleep. Either your phone is going to ring because your friend is going to call you at 7:15, or your alarm will go off, whichever one happens first. So if your friend rings you, switch off the alarm. You're finished. All right. So now this timer is put to solve the problem of a lost acknowledgement. So remember, if a frame is lost here, who's going to know about it? The receiver. If a data frame, information frame is sent to the receiver and it's lost. Let's say this one here, if number 1 is lost, the receiver will know because it will receive number 2 instead. But if the receiver sends acknowledgement, the acknowledgement is lost, who's going to know about it? The sender or the receiver? It's the sender. Because how does the sender know? The timer will go off. So if the timer goes off, the sender will know, hold on, I sent these frames. They should have gone. The receiver should have got them, should have sent me back acknowledgement. That didn't happen. So it knows something went wrong. Maybe they never arrived, none of them arrived to the receiver because the receiver is asleep. If he gets one of them, he'll wake up when he'll send us acknowledgement. Maybe none of them arrived, or at least if one of them has arrived, or all of them, And this guy sent us acknowledgement, maybe this acknowledgement is lost. So normally it means the acknowledgement is lost. So if you are asked, how does the system know? Who in the system? Which part of the system knows an acknowledgement frame is lost? It's the sender who will know. How does the sender know? It's the timer. These are called transmission timers, retransmission timers. So every time they go off, the way the receiver, the sender, if it goes to sleep and then the next thing this timer goes off, this is called retransmit. Number one will go off, that means retransmit me. So it sends number one and starts the timer again. Then timer number two goes off. Then it sends number two and starts the timer again for number two. So it will send all these frames. So this is called the timer. The timer is known as retransmission timer. What's the function of the retransmission timer? Just in case an acknowledgement is lost. So we don't leave the system hanging. We don't want the sender going to sleep and the receiver going to sleep and a frame between them is lost. No, if a frame is lost and they're both asleep, the sender will wake up. If they've sent frames, if they didn't send, then there'll be no timers. So in this system, the receiver does not have a timer, does not need a timer. The receiver will only start working if something arrives. Its system will wake it up and you say, okay, let's go. So is this clear enough? So the last error, I'm just going to mention it here, is lost acknowledgement. So what happens if you're a receiver and you get a frame with a bit error? What's your reaction? How do you solve this frame with bit error? I sent you 5 frames, 1, 2, 3, 4, 5. Number 3 has an error. What does the receiver do? Frame number 3 has a problem. But first, what do you do with frame number 3? Discard. What do you send to the sender? Acknowledgement. Acknowledgement 3. You send acknowledgement, say, hey, send me number 3. Up until 2 is good, but number 3 is. And what do you do with number 4? Discard. You understand this? So that's how you deal with this. Out of sequence, the same. If the receiver receives frame number 1, 2, 4, you say, hey, where's number 3? Number 3 is probably lost. It will send acknowledgement number 3, and it will discard everything after number 3, anything out of sequence number. So that has a bit of a little issue. I'm going to show you an example.
What will send you will send?
Pardon?
You don't receive acknowledgement.
Okay, it will wake up and it will send back. Who will wake it up? This timer, this alarm. So it will wake up and send. First, this number T1, or the timer for frame number 1, will go, and everything, like same in your mobile phone, when you want to put an alarm, you say, what is it for? And you give it the word, and then when the alarm goes, it tells you this is for your cake, or this is for your meeting, or whatever it is. So it says, timer frame number 1. You say, oh, frame number 1, this is called the retransmission time. I mean, go resend frame number 1. So take frame number 1 and send it. So it sends frame number 1 and restart the timer, put a new timer on it. And then immediately we'll go number 2, because they were created one after the other, shortly after the other. So, and then it will send number 2, number 3, number 4, and number 5. And hopefully this time, yeah, there's another error now. So we got those. All the timers restarted. We already have the copies there, and the sender goes to sleep again. Now, the receiver is waiting number 6. Imagine this. It got number 1, and 2, and 3, and 4, and 5. It's waiting on number 6. All these are not They're not lost frames. If we got number 8, then we say, hey, where's number 6? Then maybe number 7, 6, and 7 are lost. These are even before number 6. Where we want number 6, we got number 1, 2, and 3, and 4, and 5. These are all, we already received these. That's the next error. It's called duplicate error, duplicate frames. So sometimes you get duplicate frame. Duplicate frame is a frame you've already received before, or packet. If you've already received it, you receive it again, you do nothing. You just discard it and send an acknowledgement at the end of, like they'll all be sitting in the queue. That's bad, that's bad, that's bad, discard, 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 discard. Why is it discard? They're all duplicate. This one is duplicate, this one is duplicate. That's the reason. So you either discard something because it's duplicate, or discard it because it's out of sequence, or discard it because it has an error, a bit error. And when you look at the queue, there's nothing else. Well, then you send back acknowledgement. What acknowledgement do you send this time? You tell the sender, I'm waiting for number 6. I've already told you before, but okay, we'll assume that, you now say, okay, maybe that one was lost. Hopefully this time the sender will get it. So acknowledgements are very, very important frames. We can cause the receiver to empty their memory if their memory was busy. This is one of the oldest systems in all computer communication, and it's the system that works so perfectly, so precisely, so almost all computer networks use this system. Almost all, 99.9% they use this system. Even though it has a problem, and even though they brought a better system that can work better, I'll just show you what the problem is. Let's say we have a sender and a receiver, and we have window size. We're going to use modulo 128. Oh, what does modulo 128 mean? How many numbers do we have in modulo 128 for sequence numbers? 128 numbers, starting from 0. From 0 until what's the maximum number? 127. You can say 0 to 127. They are 128 numbers. If we start at 1, they have to end at 128, but always start at 0. So from 0 to 127, there are 128 numbers. That's when you get to number 128, this modulo 128, that becomes 0, and we start recycling again. The same with modulo 8. You go from 0 to 7, when you get to 8, that becomes a 0. All right, and we're going to use window size equals 100. Notice the window size always has to be less than the modulo, but for now, it's okay. And we have the time here, and this guy was going to send so many frames. You want to guess what frames this guy will send? Frame numbers? 0, 1, 2, 3, 28. No. Do you know what numbers the sender will be sending? 29. Yeah, it's the window size. Don't mix between the window size and the modulo. The modulo just gives you the full range. The window size is the one you're using on that range. Okay, so it's up to 99. So it will send 100 frames, starting from 0 to 1 to 99. If you want to be, complete in an exam question, you say keep copies of all those frames from 0, 1, 2, all the way to 99. And don't forget the timers, this timer 0, timer 1, timer 2, and timer 99. So this is completed. And sends all these frames. And got them all. Imagine, got frame number 0, 1, 2, 3, all the way to 9. And they're all perfect frames, except one frame. Number 0 has a problem. So what do you think is going to happen? What does the receiver do? Does the receiver send the frames to the user? Can't hear you. So Frame 0 has an error. So let's start. What do we do with frame 0? Discard it or send it to the user? Discard, because it has an error. Do we send something to the sender? Anytime you find an error, you send an acknowledgement. What acknowledgement number will we put in there? 0. That means there's something wrong with 0. Right. And then it will look at the next frame. Frame number 1 is perfect. Can we send it to the user? Why not? What do we do with it? Discard. Why do we discard it? Out of sequence. And the same with the rest of them. So all 99 frames are discarded from number 1 to 99. Now, the sender receives acknowledgement. What does the sender do when it receives acknowledgement 0? Can it wipe off these frames? No, nothing. It's actually acknowledging nothing. There's no confirmation that anything is good. Everything before 0 is good, but there's nothing before 0. All the frames here from 0 to 99. So that means send me the window size starting at 0. Go back to 0. Remember, in the line of numbers, we said when you send frames from 0, 0, 1, 2, 3, 4, 99, now you're waiting to send number 100. But the acknowledgement says, no, go back to 0. That's the name of this protocol. Go back to this number and start sending again. So go back to number 0 and start sending. So what will the sender send again? Come on, hurry up. All the way to 99. Problem with this system. This time, hopefully, we receive it correctly. 0 is okay, 1 is okay, they're all okay, all the way to 99. And we send them to the users, and we send back acknowledgement. What acknowledgement will we send back? 100. That means we've received up to number 99, and we are waiting number 100. That's the way the system works. But can you see any problem with this system? Because there was something wrong with frame 0, all the rest of the frames from number 1 to 99, 99 frames were sent correctly. They were received correctly. There's nothing wrong with them except one thing, out of sequence. But they took a lot of time to transmit the transmission of 99 frames. They could be even more. They could be 200 frames, depending on the window size. And they were transmitted all correctly. And because one frame before them had a problem, they all had to be deleted and have to be resent again. Well, that's not good on the transmission channel. We are not really using the transmission channel very efficiently. We're sending big number of frames twice. And there was nothing wrong actually with sending them the first time. The first time there was nothing wrong with them. There was something wrong with the frame before them. So this is what's wrong with this system. This is the disadvantage of this system. That sometimes very good frames are received, but they're discarded because the one before them has a problem. And that's bad for the transmission channel. That means we have to send them again, even though there was nothing wrong with them again, and there could be a huge number of packets or frames. You understand the disadvantage? So somebody came up with, they improved the system, they produced a better system, but in the newer system, so this is called the go back in. If you're asked what's the disadvantage of go back in, one disadvantage, that's all. It's a perfect system except for this disadvantage. Disadvantage that it's bad for using or utilizing, if you want to be a little bit more technical, utilizing the transmission channel. And if you're asked to explain it, what do you mean? It doesn't use the channel efficiently. It sends good frames. If one of them is not good, that's a front, like especially the worst case. This is the worst case I showed you. If number 1 is bad, the first frame is bad, then all the remaining frames, the following frames, are discarded, even if they are good, and they are sent again. That's the problem with go back in. So somebody said, okay, they introduced a newer system. How are we doing on time? Okay. This is called selective reject, or sometimes they call selective repeat. Both names or words are used in textbooks. So this is the other algorithm. It's almost the same algorithm. It uses window size, it uses modulo, and the sender sends, and their timers, everything is the same, except one simple rule. They changed it, and it works much better, but at a cost. Okay, so let's do it again. Sender and receiver, and this guy, window size 100. Okay, no, let me give you an example, not 100. Let's just go back to 5, window size 5, and modulo 8, just to understand how the selective repeat or selective reject works. And this is time, just to make it a little bit easier. So the window size 5, that means this guy sends 5 frames, 0, 1, 2, 3, and 4, and keep copies of those frames, and keep timers, start timers off, right? Don't forget these. If you're asked to describe either of those two systems and you describe it, you don't put the copies, you lose 1 mark. You don't put the timers, you lose 2nd mark. So make sure you put them. And when you put, make sure the line goes down a little bit. So in time, you're arriving later. You don't send something you arrived 2 minutes ago. You arrive 2 minutes later or 2 milliseconds later. But anyway, this guy got 0, 1, 2, 3, 4, got them. Right. Let's say in the past, in this system, in the go back in, frame 0 is good, we send it to the user. Frame 0 is, number 1 is bad, has an error. We discard it, right? And in the other system, discard everything else after that, because they're all out of sequence. Now, with the selective reject, they're not out of sequence. That goes to the user. This is discarded, and we send back now something called negative acknowledgement. Not acknowledgement, negative acknowledgement. N-A-K, NAK, negative acknowledgement. That means with the number of the frame that has the problem. So number 1, in the negative acknowledgement, that means please only send me this frame. That's what it means. Remember, with the acknowledgement, if I send you acknowledgement 1, that means everything before 1 okay, but everything after 1 is not okay. Send me 1 and 2 and 3 and 4. With the negative acknowledgement, now, can you just send me number 1? That's all. And we look at number 2. Now number 2 is good. What do we do with it? We cannot send it to our user because it's out of sequence. But what we do here, we buffer it. We store it in memory. Buffer it. What about number 3? Let's say we check number 3 has an error also. What do? We send back a NAK. As you notice here, every NAK belongs to 1 frame only. Before the acknowledgement, we can cover any group of frames. It starts at 1 frame, but everything after. NAK 3. What does NAK 3 means? Means, yeah, send me only number 3. There's something wrong with 3. Missing, maybe something wrong. We don't know what's wrong with it, but there's something wrong, and I need a copy of number 3. Right. And then, so that's discarded, obviously. Number 4 is good. Can we send it to the user? No, but keep it in memory. So now we need memory for this guy, for the receiver. And this system, the selective reject, we need memory for the receiver as well. Of course, the sender has to keep copies of all the frames. The receiver also needs to keep copies of the frames that follow a bad frame. All right, so in time, this guy gets this at this time. Oh, you want a copy of number 1? Here it is. So it just takes a copy and sends it. So number 1 is gone. And goes to sleep, waiting on an acknowledgement. But it gets another negative acknowledgement at a little bit time later. Oh, you want number 3? Here's number 3. So just send 1 frame. All right? This guy buffers this and goes to sleep, waiting. And then it gets number 1. Gets number 1, says, okay, and it's good. What do we do with it? We send it to the user because remember, let's start with this again. When we start first, the receiver also has the next frame I'm going to receive is 0. When it starts first, it's waiting on 0. It got 0. Send it to the user and increment the 0. It becomes now I'm waiting on number 1. I got number 1 but has a problem. I'm still waiting on 1 to send to the user. We got number 2, store number 2. So we have here number 2. And we have number 4. So number 2 and number 4 are in my memory. I can't send them to the user. Now we got number 1. Number 1 is good. Send it to the user. So the line goes up. That's what I'm waiting on 1. We got 1. So increment this, and now we're waiting on number 2. Send number 1 to the user. Number 2, we already have it. We already have it before. We store it in our memory. We send it now to our user, and now we're waiting on number 3. Okay, that's it. Can we send 4? No. We just go to sleep until number 3 comes. So number 3 arrives suddenly. It's good, and that's what we're waiting on. We send it to the user, and then we already have number 4 here. Everything is gone to the user. We have nothing in memory. Now we can send acknowledgement. There's nothing in the queue, so we send acknowledgement. What acknowledgement number we send back? Received 0, 1, 2, 3, and 4. Okay. Number 1 and number 3, there was something wrong with them. We sent NAC, we got them, but we are okay now. So we got all the way to number 4, we sent them to our user. What acknowledgement will we send back to the sender? 5. That means up to number 4 it's back to normal now. So this NAC only works if there's a problem with one particular frame. But as you can see now, we didn't resend all the frames. Imagine if we go back to that system, window size 100. Window size equals 100. That's another system. Okay, this guy sends frame 0, 1, 2, 3. We just repeat that problem we had earlier, all the way to 99, and keeps copy of all those frames from 0 all the way to 99, and timers as well. This guy gets all the frames 0, 1, 2, 3, all the way to 99. There's something wrong with 0, and everything else is good. What happens here in the selective reject? This is selective reject. This is the modern system. 0 has a problem. So what do? We send a NAC, negative acknowledgement. What number in it? 0. There's something wrong with 0. Can you please send me 0? But number 1 is okay, 2 and 3. What do? Send them to the user? No, buffer them. Keep them on our memory. We're waiting on number 0. So hopefully the sender will get this NAC, send us number 0. We get 0, okay. Send it to the user, and then follow it by 1, 2, 3 all the way. So see, this system, the newer system, the selective reject or selective repeat, you don't repeat everything. You only repeat the one that has the problem, but the others, you keep them in memory. And when that problem is sorted out, we can give the rest to our users. So we don't have to retransmit all these frames. Remember with the go back in, when we done the same thing, we had something wrong with number 0. We sent back acknowledgement 0. That means, hey, there's something wrong with this frame. Number 1 is out of sequence. Number 2, discard everything. With the old system, we discarded all the good frames until we got them again. But here, we don't discard them. We keep them on buffer, and we only ask for the missing frame. So that's the only advantage the selective reject or selective repeat has over the go back in. The go back in is still the best system and still the most used system. But it has a problem, and this protocol or this algorithm fixes that problem, but at a cost. It didn't fix it for free. What's the cost? Memory. Now we need more memory at the receiver. Remember, with the older system, almost no memory is required at the receiver, only one space for one frame. Now, if we have window size 100, the sender must have enough memory to store 100 frames because it has to send them and keep copies. And also the receiver, how much memory, how many frames does the receiver, the maximum number of frames it needs to keep if something goes wrong? The worst case, if the first frame goes bad, We don't have to keep the first frame discarded, but we have to keep everything else. So it's the window size minus 1. So this guy, if our window size is 100, the sender must have enough memory to store 100 frames. The receiver must have enough memory to store 99 frames. That's the maximum requirement. Is that good enough, guys? Hey, so I'm going to start same question I start to do. What's the window size? That's the word I was looking for. It's the maximum. What's the window size again? Okay. When does the retransmission timer come into operation? Yeah. Right? What's this one? Timers. When does the timer come into operation? When does the timer go off? Which frame? Okay, let me ask you another thing. If a frame is lost, I sent you frames 1, 2, 3, 4, 5, number 3 is lost. Who discovers that? You as a receiver or me as a sender? The receiver discovers. How does the receiver discover it? If it finds it's waiting frame number 2, got number 4, and say, hey, I'm waiting for number 3. So yeah, okay, so it's out of sequence. What happens if the acknowledgement frame, you send me few frames, 1, 2, 3, 4, I send you acknowledgement 5. Acknowledgement is lost. How does the sender know the acknowledgement is lost? He did not get the acknowledgement. The timers will go off, the retransmission timer will go off. Does the receiver need a retransmission timer? In any of those protocols? No. Acknowledgement 0, what does it mean? Give me one thing, acknowledgement, you've got acknowledgement 0, what does it mean? Everything before 0 is received. Anything else? And that's what I'm expecting is to receive frame number 0. What else could it mean? Yeah, what else? No. Acknowledgement 0. They could be, maybe you sent me frame number 0 and there's an error in frame 0. What else? When would I send you acknowledgement 0? Other than, hey, everything before 0 is okay and I'm waiting for a 0 and maybe there's something wrong with 0. Error. Is there any other reason why you might receive acknowledgement 0?
And if any other frames are not okay in receiver, we can send the acknowledgement receiver. Because maybe there is no other frame before 0. All frames are covered.
Okay. Out of sequence, if frame 0, if I instead I was waiting for 6, 7, and I'm waiting for 0, I got 1. So it's lost, frame 0 is number lost. So I say, where is 0? I send it to you. So it could be out of sequence. Okay, and what's a modulo? What do we need the modulo for? What does the modulo define in this communication system? I'm going to let you go soon. Why do we need a modulo? What does it say?
Maximum number.
It defines the sequence range, the range of the sequence numbers that we will use from 0 to the modulo minus 1. Okay? But the window size is different. The window size must be smaller than the modulo. It moves on the range of sequence numbers. Which one is better? The go back in or the selective reject or selective repeat?
That's all memory.
Okay.
If you don't want to use memory, and first one is better.
Okay. So if you want to save memory, go for the go back in. If you want to, and what's the problem with go back in? What's the disadvantage of go back in?
If you have problem in the first frame, you need to send all other frames also.
Resend the frames again, and they call this, well, this is utilizing, not good for the transmission channel. We are repeating good frames, we send them again. Okay, guys, have a good weekend. Well, no, so I'll see you Wednesday, Friday. Do we have
I don't have attendance.
attendance, guys? Okay, 1 second.